Hello there, this is Mr. Chen, about to do an Algebra 2 lesson, 3-2, called Adding, Subtracting, Multiplying Polynomials. Go ahead and grab your student companion note taker and let's see, turn to page 65. Here we go. So the opener kind of focuses on some properties that we learned in Algebra 1 back in the old days. We have something called the associative property. We have the commutative property. And of course, the distributive property. Let's go ahead and summarize those properties, starting with associative. Here we go. Whoa. The associative property is referring to how three numbers are related to each other when it comes to addition. If you add two of them last, and then the first one after that, you'll get the same answer if you add the first two and then the last one last. So a plus parentheses b plus c, you'll get the same answer as adding a plus b first and then c last. That's the associative property for addition. Commutative property is referring to how numbers move around, hence the idea of commuting or commutative. Adding two numbers in reverse order, you'll get the same answer. Order doesn't matter. Those two properties also apply to multiplication. So let me write that down. Closed under addition and multiplication. We don't have any properties for subtraction or division because they would not work at all. The distributive properties next. Something you saw from Algebra 1. I literally can represent this using rectangles. Here we're finding areas of those little rectangles, basically. A times B will give you AB, the product that is, and then you add it to the other little rectangle, A times C. So these properties should look very familiar from Algebra 1. That was just a nice little introduction. I'm going to go ahead and switch over to the next page. Any questions about these three properties? We're going to be applying these all to polynomials, okay? That's the key today. We're just going to apply those properties. Next page. Here we go. All right. So some things from back in Algebra 1, when it comes to adding, subtracting terms of a polynomial, you want to combine like terms. That's the key now. It's like going out trick-or-treating. Afterwards, you want to sort all your candy, put them in piles, all the M&Ms in one pile, all the Snickers in another pile. We do the same thing with variables and numbers as well. Multiplication and division of terms of polynomials. You want to follow those properties of exponents. From your previous math class. All right, let's get going here. Example 1 has 2 examples, sub-examples, just adding, subtracting, not that big of a deal. And because our first one's addition, I can just ignore the parentheses. So I'm going to go ahead and just highlight the like terms from each of those polynomials. Oh, look, I have 4 of those a to the fourth, and I don't see any other a to the fourth in the second polynomial in the parentheses. So I'm going to move on and look for another term. How about a to cubes? A to the third, oh look, I'm going to use orange there to signify those are like terms. A squares, I'm going to use green. A's, I'm going to use blue. And the constants, I'm going to go ahead and use purple. And now all I'm doing is I'm going to combine like terms. You are going to add the coefficients. So A's are first, 4a to the fourth. There's no other one there. And then let's look at the a cubes. We have -6 plus 5. -6 plus 5, that's -1, a to the third. Technically, you don't have to put the 1 there, but I just do it for emphasis. How about the a squares? They're -3 plus 7, that's +4, a squared. How about the single a's? We have one of those a's, there's an invisible 1 in front of that a right there, plus 2 is 3. And finally, constants, we have 1 plus -2 is -1. And ladies and gentlemen, there's your answer right there. Pretty easy. I don't think we need another one of those addition problems. Let's go and move on to subtraction. Now, subtraction is a little different, isn't it? Right? Subtraction here requires you to apply a -1 to the back polynomial. Make sure you do it carefully. I would highly recommend you rewrite this whole thing without parentheses and applying that minus sign to the second half. Here we go. -3a squared b squared plus 9a squared b and -7ab squared. Okay. Let's look for like terms. Are there any a squared b squares? Oh yeah, look, there they are. 2 minus 3 of those a squared b squares is -1 a squared b squared. So those are done. How about ab squared? Oh yeah, we do have some ab squares. There's one right there, and here's one right there. And in that situation, we have 3 minus 7 is -4 ab squares. Great. One more. Take a look here. A squared b's. No, those are two are like terms. -5 plus 9 is +4 a squared b's. Yay. There's your answer. Any questions? When can you combine two terms using addition or subtraction? They must have the same combination of variables, same number of variables. All right. So that takes care of adding, subtraction in example 1. Let's move on to example 2 involving multiplication. Now, the best way to do these for some kids is to draw a rectangle. In this case, we have a binomial times a trinomial. The rectangle I just drew shows a 2 by 3 rectangle, represented the polynomials off to the left there. I'm going to go ahead and write the binomial first, 6n, whoops, wrong color, 6n squared minus 7 along the edge there for the binomial, and then we have n squared plus n plus 3. Okay? So you can do distributive property or FOIL. You can do this if you like. Here we go. 6n squared times n squared is 6n to the 4th. Remember, there's an invisible 1 right there. 6 times 1 is 6. N squared times n squared is n to the 4th. You add the exponents. That is the property from back when. Let's keep going here. Multiply 6n squared times n. Again, there's a 1 right there. 6 times 1 is 6, n to the third this time because there's an invisible 1 right there for that n. Let's keep going. 6n squared times 3 is 18, n to the second power. Okay, that's 1/2 of the distributive property. The second half, I'm going to go multiply by -7 to that trinomial. We have minus 7n squared. -7 times n is -7n. And finally, -7 times 3 is -21. And you got to be careful here. After multiplying a binomial times a trinomial, we have 6 terms. Those 6 terms, some of them can be combined together. Now, this is kind of interesting. There's only 2 terms that I see that are the same like terms. Those are the n squares. Everything else is basically on their own. So my final answer is, dun, 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 look in the box here, 6n to the 4th plus 6n to the 3rd. And the middle 2 terms out of the 6, -7 plus 18 is plus 11n squared. And then bring everything else down. I'm kind of in the habit of putting this in descending order. Standard form makes life easier for the teacher. There it is. Yay. Letter B, holy cow. We have a product of 3 binomials. Ooh, and this is kind of going to be messy. Multiply 2 at a time. I'm going to multiply these 2 first. Let's do that. I'm going to just use FOIL here. Mn times m squared n is m to the 3rd n squared. Okay. Let's do the outers next. Minus mn, inners are next, plus m squared n, and last one is -1. Great. Looks like none of those can be combined together. I'm going to go ahead and bring this binomial down. Ooh, this is a lot of m and n's. I'm going to go ahead and, throw this into a box. It looks like a 4x2, or I'm going to just switch the 4x2 into a 2x4 because of space allotment here. Let's do that. Kind of like the last problem. Okay, here we go. Mn squared plus 2. And the 4-term polynomial is along the top edge. All right, here we go. Let's go ahead and multiply. I'm doing this crazy thing. Mn squared times m cubed n squared is m to the 4th, n to the 4th. Let's keep going. Minus m squared n to the 3rd. Let's keep going. Plus m to the 3rd n to the 3rd. And then finally, 1 minus mn squared. Wow, this is a tongue twister. Next row is a little easier. It's going to just tack on a 2. Very nice. 2m cubed n squared minus 2mn plus 2m squared n minus 2. Let's take a look at these 8 terms that we got and see if any of them can be combined together. What? You're kidding me. None of these have the same combination of variables. That's your whole answer right there. Ugly. The order is a little messy, isn't it? Wow, there it is. That's quite a mess. Whew. All right. Is the set of polynomials closed under multiplication? Yeah, it is. I mean, if we make couple of problems here. 3x times 4x will give you the same answer as 4x times 3x. Order doesn't matter here. Next page. All right. Ooh, we haven't had a word problem in a long time. The cost of Carolina's materials changes so that her new cost function is C of x equals 4x plus 42. Find the new profit function, then find the quantity that maximizes profit and calculate the profit. All right, so obviously we are missing some information here. I want to go ahead and give you the information from the book itself. Here it is. Write it off to the side. V of x equals to 48 minus 2x. Vx is the price. X is the number or the items. The graph itself in the book looks like this. I don't know, sometimes these note takers don't give us everything. Whoa. There's a cost function. $12x plus 64. Oh, I see what I did last year. I'm not using the one that's in the note taker right now. I'm doing the one in the book first, okay? So that 4x plus 42 we'll do in a second. Right now, all we're doing is just going to go ahead and do the one in the book. All right, here we go. Before we can even do this, you have to know the relationship between profit, revenue, and cost. Profit's how much we make at the end. That is equal to the revenue, meaning the money that we get from consumers. But there is a cost involved that takes away some of the profit. So there's your generic equation. Revenue is actually price times the units sold. The word unit, cost, profit, and revenue are very generic. We don't even know what we're buying or selling, but this is fine. So we need a profit function in this case, P of x, that equals to, in this case, the key is to subtract those two functions that were given to us in the book. We're going to take the revenue, in this case, 48 minus 2x, and subtract away the cost, okay? That's all it is. All right, so it's just basically 48 minus 2x minus the other one, 12x plus 64. That's it. Distribute the minus sign and clean this algebraic expression up. And we have a function. This equals 2. Let's take a look here. Oh yeah, I lost that squared, didn't I? Haha. That should be 4x squared. Oh. Okay. I see what I did wrong. Back it up a little bit. Forgot to multiply by the profit part. Okay? So please forgive me. I knew I made a little mistake here. That part goes in right here. 48 minus 2x times x, the number of units. Forgot to include that part. Sorry about that. So I do need to distribute that x to here and there, and that will give me 48x minus 2x squared. And then we need to apply the negative sign to the back half of this problem. Much better. Sorry about that. So now let's go ahead and clean this up. My profit monk, I'm going to put it in descending order, negative 2x squared. 48 minus 12 is 36x plus 64. All right, so I kind of jumped ahead and graphed the function here ahead of time off to the left here. I should have left that blank, sorry about that. But when we graph this new profit function, it's a parabola. Whoa! Using the graphing calculator's function, I can find the maximum profit. I mean, we can use the formula negative b over 2a, or just use the calculator and let us figure it out for us. I noticed another little boo-boo here. That 64 should be minus 64. Sorry about that. All right. So when I put this into the calculator and find my maximum, that maximum right there on the graphing calculator comes out to be 998. Woohoo! So that's my maximum profit based off of the vertex of this inverted parabola, and it comes out to be, and I guess, I apologize, in this book, I didn't mention it in the first place, selling 9 wind chimes? I'm a little embarrassed I didn't mention this myself. Results in $98 profit. That's in the book, okay? One interesting little tidbit that I want to point out. If you sell nothing, you will be in the hole $64. Okay, that's the y-intercept. All right, are there any questions? I'm going to go ahead and write down what the note taker's results would be right here off to the right. Again, word problems can be tricky. They do require a little extra practice. So it's almost the same problem, but the note taker's cost function is a little bit different than the one in the book. Distribute the negative sign, distribute the x this way, and ultimately, with this scenario, we get a final answer of negative 2x squared plus 44x minus 42 for my profit function. Interestingly enough, on the graphing calculator, and I know I'm kind of skipping some of that, this particular function has a different maximum. In this case right there at 11 and $200. Wow, very nice. 11 wind chimes, $200. I don't know about you, that was a little bit lengthy there. I'm ready for the last page. Let's go ahead and do it. We're going to skip number 5. All right. Last page. Here we go. Yay! Some more adding, subtracting. Let's do it. Let's do number 5 here off to the right. We have some like terms here. Negative 3 plus 1. That was easy. 2 minus 3. Nice. Ooh, we don't have any 5a, any a's anywhere, so that's by itself. But we do have constants, negative 4 plus 7. And there it is, yay. There's my answer for number 5. Any questions on number 5? Number 6, we do need to apply a minus sign to those 4 terms in the back of the polynomial. Rewrite the whole problem again. Make sure you change the signage for each of those terms in the back. Looks good, looks good. Combine like terms. Any x squared? Oh, yay. X squared, y squared, 7 minus 5 of them. Very nice. Any x cubes? Sure, here they are. Negative 6 plus 1 x cubed is minus 5x cubed. Nice. And then finally, ooh, interesting. The xy's do cancel out. 1 minus 1 goes away. And then finally, the last term is minus x. There's my answer. Yay. Any questions about number 6? That takes care of adding and subtracting. Number 7 and number 8 are about multiplication. Let's deal with that. Number 7, you can throw in a box, or you can just do the distributive property multiple times. Let's do the distributive property. I want to show you a technique here. 7 times 2 is 14, a to the third. That's my first product right there. Let's keep going here. Minus 35a squared. And then my next distributive is plus 21a. Now, whether you use a box or not, if you don't, you can always line up the terms as you go. All right, the back half of this distributive property, 2 times 2a squared, will give me 4a squared. I'm going to put it right here. I'm lining up the terms and they're ready to go vertically. It's just a technique to save some time. 2 times negative 5a is negative 10a. And then, of course, 2 times 3 is 6. So all I'm doing is just lining them up and adding the terms themselves. Okay. Pretty easy. Now give me my final answer, 14a to the third. Ooh, what's this? Minus 31a squared. Ooh, plus 11a plus 6. And there's my answer. Yay. Ooh, I'm looking at number 8. Any questions about number 7? All right. Number 8, one of those we got to do 2 at a time and then worry about the last one last. Okay, fine. Here we go. Xy times xy is xy squared y squared. Xy times 6 is plus 6xy. Let's do the next one here. Minus xy. Oh, okay, I'm going to put right here, I think. Good. And then minus 6 right there. So the product of those two binomials added together will give me x squared y squared plus 5xy minus 6. Bring down the other binomial to be multiplied with that thing I just got. Ooh, this is going to be very messy, isn't it? I think I'm going to go ahead and just go crazy here. Here we go. All right, wish me luck. X squared y squared times xy is x cubed y cubed. All right. Next one, I'm going to do, whoa, minus 8x squared y squared. All right, next one. Let's do this. 5 times 1 is, don't be careful. Some people might call it a 6. 5 times 1 is 5x squared y squared. Oops. I'm lining it up. Minus 40 xy. All right. Next, here we go. Minus 6xy. And negative 6 times negative 8 is positive 48. So you notice I'm lining those terms up. And they're ready to be added all together. Here we go. X cubed, y cubed, nothing else. Minus 3x squared, y squared, minus 46xy, plus 48. And I think we are done. Yay. Wow. Quite some work there. Well, ladies and gentlemen, we are done. Hope you were able to put that all down. If there are no questions, please ask. Thank you very much. Have a good day.